Watch how turning this knob changes the LED's brightness. What's really happening here is voltage control, the simplest example of Ohm's law and the voltage divider in action. This potentiometer splits the 9 volts between its two sides. The pin in the middle, the wiper, outputs a fraction of that voltage to our LED. The resistor keeps the current safe while the pot adjusts the brightness. Well, let's test Ohm's law by setting up a simple circuit. We'll use a 1 kiloohm resistor. We can see that even with a 1 kiloohm resistor, our LED lights up. Now we need to test the volts across the resistor and also disconnect this probe and test the amperage. Disconnecting this side of the circuit allows us to put our multimeter in parallel with our LED. And we see about 6.9 milliamps, which means we should see around 6 volts across our resistor. Switching our multimeter from amps to volts and reading across the resistor, we see 6.6 volts. Let's check how the math lines up with what we measured. The resistor dropped 6.6 volts, and it's a 1 kiloohm resistor. Divide 6.6 by 1000, and we get 0.0066 amps, or 6.6 milliamps. That matches our multimeter reading almost exactly. That tells us that the resistor is doing exactly what Ohm's law predicts. The rest of the voltage, whatever is left from the battery, must be dropping across the LED itself. If we treat the LED like a resistor, for just a moment, we can estimate its effective resistance, basically how much it resists current at this brightness. So, right now the LED behaves like a 350 ohm resistor, but that's not a fixed value. It changes with current and temperature, which is why LEDs aren't modeled as simple resistors. Our math checks out. Next, we'll use the same ideas to see how a voltage divider controls voltage on purpose instead of by accident. Now, if we connect two resistors in series, the voltage splits between them. This is a 20 ohm and a 10 ohm resistor. We can connect one from power into any socket, and then the other side into ground. Since we're using a 9 volt battery, we should see in the middle of these about 6 volts. And we see exactly 6 volts, which means with a 10K and a 20K, we get roughly 6 volts at the midpoint. Now let's look at the math behind the voltage divider. Two resistors in series, so the same current flows through both. The total resistance is just R1 plus R2. Ohm's law tells us that current equals the supply voltage divided by the total resistance. The output voltage is dropped across the lower resistor, R2, using Ohm's law again, that's the current times R2. Now, substitute the expression for the current. That's the key voltage divider formula. It tells us the input voltage splits between the two resistors based on their ratio. In our case, R1 is a 10 kiloohm, R2 is a 20 kiloohm, and the supply is 9 volts. Therefore, we get this. That's exactly what the multimeter shows, 6 volts out of the 9. This potentiometer is a variable divider. By turning the knob, we see our voltage begin to drop. That's because it's increasing the internal resistance in the circuit. Fully turning the knob, we see no voltage. Turning the knob the opposite direction completely, we see almost the full voltage from the 9 volt battery. plus or minus about 2 volts. By changing the resistance ratios, we change output voltage. That's the essence of a voltage divider. If you found this video interesting, remember to like and subscribe. It really helps me out. Thanks.